Hello, welcome to VMworld and to our Telco track in our session for today, preparing the Telco cloud for 5G and cloud native. My name is Phil Kippen and I'm a Senior Director in our Telco and Edge Cloud business unit. And I'm joined today by Dmitry Andrushko, who's a Senior Consulting Technical Architect in our Telco and Edge Cloud business unit. We're going to be talking today about automating real-time configuration for performance-intensive network functions. So for those of you who've tried it, it's a lot easier said than done, but we have a new product, a new platform called our Telco Cloud Platform that's going to make it a whole lot easier and operationally efficient for our service provider customers. But before we get there, this presentation may contain product features or functionality that are currently under development. This overview of new technology represents no commitments from VMware to deliver these features in any generally available product. Features are subject to change and must not be included in contracts, purchase orders, or sales agreements of any kind. Technical feasibility and market demand will affect final delivery. Pricing and packaging for any new features, functionality, technology discussed or presented have not been determined. Okay, so now that we're past that, let's talk about VMware's vision for delivering the digital foundation. Specifically, VMware's vision for delivering our customers a platform that can deliver any application from any cloud to any device with intrinsic security and scalability. Now, when you think about that in a service provider context, it becomes incredibly challenging. Hundreds of millions of devices, tens or hundreds of thousands of applications, and then tens of thousands or thousands of clouds with multi-access edge and far edge clouds and extensions from service provider to enterprise clouds. When you think about the requirements that service providers have and trying to realize our vision, it's incredibly challenging to do. But that's what we do in the Telco and Edge Cloud business unit at VMware. And we have built a new platform and just announced a new platform that is realizing our vision by delivering any application from any cloud to any device with intrinsic security and scalability, and also meets our service provider carrier grade scalability and requirements. And that platform is called our Telco Cloud Platform. Our Telco Cloud Platform essentially has three components or three parts to it. The first part is our Telco Cloud Infrastructure, and that's our SDDC stack, or our compute, network, storage, plus OpenStack and vCloud Director as virtual infrastructure managers for multi-tenancy. And then as well, our Kubernetes distribution, TKG, for container-based service delivery. On top of our Telco Cloud Infrastructure platform, we have Telco Cloud Automation. It's not your normal automation platform. It's actually a very innovative automation platform that takes essentially domain orchestration and CAS management and also infrastructure management, brings them all together and takes the synergies that creates and some new features and capabilities, innovation that's come from that, and leverages it to really kind of change the game and help our service providers really make an impact with respect to reducing the cost of operations and fully automating the processes and the services that they're delivering to their customers. So Telco Cloud Automation, a lot of innovation going on there, certainly a lot to talk about. We'll be talking about two of those features today. Telco Cloud Operations is really about intelligent service assurance, right? Telco Cloud Operations, we're not only able to see whether or not the service provider or the service is up or down, we're also looking inside the service at intelligence about the service to be able to tell whether or not, even if the service is up, is there degradation or is there a problem, for instance, with interference, and be able to correlate that across domains, perform root cause analysis and figure out how to fix that problem, where the problem occurs, and then how to fix it. So we're past looking at whether or not the service is up. We're now looking inside the service to really understand the experience that customer is having with that service and helping service providers map that to their KPIs that they and their customers have agreed to deliver on. So with Telco Cloud Operations and Telco Cloud Automation and Telco Cloud Infrastructure, we have a single platform for service provider service delivery for 5G and cloud native services. And certainly all of the components in these three layers can be used across core edge, RAN, and also private 5G. I would love to know if anybody's surprised by these numbers. Some operators face labor costs in excess of 50% of revenues. So for those service providers out there, does this seem to be the case? Or is it 15% of revenues? We've seen a lot of different numbers. I guess what's common between these numbers is that there's a lot of room for improvement, especially in operations. And as we move to cloud native and 5G service delivery, the operational complexity is going to grow. And so there's even more room for improvement. We're focusing a lot of our time and innovation within our platform on trying to reduce operational costs for our service providers. And specifically bringing these numbers down as far as we can get them by automating processes, application delivery, the deployment of data centers, as well helping our customers with better visibility and certainly trying to help them troubleshoot and eliminate problems faster. So our Telco Cloud platform is very much focused on operations and very specifically targeted to address these numbers and help our service providers bring those numbers down as a percentage of revenue. The three areas that providers continue to tell us contribute largely to those costs, specifically the operational costs and challenges, are really application onboarding, preparing the application for the environment, getting it ready and in the environment to deploy, and then also infrastructure lifecycle management, which is really about maintaining the infrastructure licenses, adding new infrastructure, removing or replacing, migrating infrastructure, and then also application real-time lifecycle management. Now that's all about the things you need to do to help the application run in real time or in runtime, but being able to do them real time. So think of it as a set of capabilities that need to be in place in runtime, in real time. So when you're deploying an application, for instance, you might make configuration settings to optimize that application runtime. And so I've got a number of things here on the right-hand side that we're doing within our Telco Cloud platform across all three of these areas. But the two that I'm going to talk about today are dimensioning and real-time environment customization, which are really related to the application real-time lifecycle management capabilities that we're putting into our platform. So dimensioning, why is it important? So dimensioning is important because we're allocating resources. And if we allocate resources before we understand how the application is going to use them or what the application needs, then we could waste those resources. So for high performance applications, for instance, that need dedicated resources, we are going to provision resources differently for those applications than we would for applications that don't require dedicated resources for performance. So we've got a lot of different types of applications that providers are provisioning out there, and especially when we talk about Kubernetes and worker node provisioning and the ability to oversubscribe the worker nodes, we don't necessarily want to just make one decision in advance of knowing what applications are going to be delivered onto those resources. So what dimensioning is about making those decisions, those dimensioning decisions on how to align those resources, and specifically things like oversubscription, to the application needs in real time as you're deploying the application, instead of doing it in advance. So what you're doing is you're optimizing or conserving your resources and aligning your resources to application needs. You're not wasting resources, essentially, by allocating resources that aren't going to get used. So dimensioning is incredibly important to cost savings, but also to making sure that you have enough resources for those performance intensive applications that you need to deploy for critical services. And then we have runtime environment customization. This is setting things like SRIOV or setting huge pages, those configuration settings that enable those applications to leverage capabilities to optimize performance. And so the ability to make those configuration settings at the time of application deployment is what we're talking about here. So rather than configuring SRIOV in advance for a whole bunch of different capacity or a whole bunch of capacity, we're going to configure SRIOV real time when we need it and only for the applications we need it for, right? So again, here we're not only automating the workflow and the process, but we're also doing it real time, which saves us a whole lot of advanced work on the front end. There's nothing worse for an operator than hitting deploy, on your orchestrator and then having a red screen come back and say, go configure SRIOV for all these interfaces manually and then come back to me, right? So within our Telco Cloud platform, and specifically Telco Cloud Automation, we've automated those configuration parameters, and we've automated the setting of those configuration parameters when the application is deployed as part of that application deployment workflow. So between dimensioning and runtime and real-time environment customization, we have two key features here that demonstrate how we're leveraging the capabilities of our automation platform, also the capabilities within our infrastructure platform, but also all of the work that we're doing as we certify applications and understand the applications that are being deployed on our platform, helping customers and providing them with artifacts that show what the applications require in terms of resources and configuration settings, and then providing an automation platform that understands those parameters, that metadata, and is able to take action in real time as the application is being deployed, saving the operator a ton of time on the front end. And so Dimitri is going to demonstrate both of these capabilities today, both dimensioning and what we call custom or late bindings. And you'll see how the platform does this all in one single workflow. So take it away, Dimitri, and amaze everybody. And we'll continue to answer questions during the session.
Thank you very much, Phil, for introduction. And let's start with the demo. So right now we see main screen of the Telco Cloud Automation product, and we have several CNFs already uploaded into our NF catalog. Today, during the demonstration, we'll instantiate Nokia UPF network function and demonstrate how worker node dimensioning and customization really works. So let's start with network function instantiation. At first, we select network function from our catalog and just click in instantiate. In the new window, we'll see the content of the CNF package. So here we'll see content of the VNF descriptor, basically YAML file, which is formed according to ETSI specification, and set of additional artifacts. This network function is built according to ETSI standard and according to appropriate specification. And inside of the VNF descriptor of our CNF, we might see several extra fields, which allows us to produce several funny features like customization and adding extra capabilities to our network function. So here we, for example, see that to instantiate this network function, our infrastructure should align with certain requirements. Basically, we should be able to have required kernel version and some custom packages. Additional to this, certain CAS components like CNI should be deployed in our cluster. So here we see that during the deployment, TCA will customize our infrastructure to be able to satisfy UPF requirements. Basically, kernel version will be modified to one which is specified. Custom package will be deployed into the worker node, and set of CNIs will be post-deployed into the infrastructure for UPF to be successfully deployed. All this specified inside of the CSAR archive and coming as predefined with CNF package. So let's go ahead and try to instantiate this network function. On the first screen, we'll see a set of basic parameters which we should provide for network function to be instantiated. Definitely, we should provide custom name of our CNF instance. Let's call it UPF for this case. And next, very interesting question. We should provide a destination cloud for our network function. In our deployment, we might see that we already have several clusters which were pre-deployed and which might be used for this deployment. you might see that some of them marked by green is compatible, but one of them called VMworld Demo is not compatible. Let's check why it's not compatible. Basically, we might see that inside of this cloud, we have set of worker nodes called worker demo group, and this is a group of the worker nodes which will be used which might be used for the network function to be deployed, and this set of worker nodes should have certain capabilities which are required for CNF to be successfully deployed. Right now, we see that it's not fully compatible. And if we'll select this worker node for deployment, we'll see that set of additional requirements should be met by our worker node. Basically, we see that certain customization is required. At this screen, we see that our current worker nodes had set of existing capabilities. Basically, we see a version of the kernel like 4.19.1.15, and we see existing set of existing packages and configuration which is already pre-deployed. However, according to the CNF specification, we have set of desired state which should be available at our worker node infrastructure. So we see that special real-time kernel should be deployed. Set of packages should be available inside of the worker nodes, and definitely some CNIs should be deployed too. All these are desired state of our worker nodes for successful deployment of the CNF. This means that before CNF will be deployed, set of additional operations should be performed by the TCA. And basically all these requirements should be satisfied. Before any CNF will be instantiated, we should ensure that certain packages are deployed and available inside of the infrastructure. Okay, on the next screen, we are selecting a repository which should be provided for the network function to be deployed. And inside of all repositories which are available, we select one which stores Helm charts and images for our network function. Let's select Nokia 1. And yeah, we're selecting one, the one on the list. Okay. And on the next screen, as you can imagine, we should provide set of additional parameters required for our network function to be instantiated. Basically, we provide set of parameters required for Helm charts to be instantiated, and this is coming in the form of input YAML file, which is used for deployment. Well, let's specify it. And immediately we'll see a set of input parameters which are used by network function internally. And then we should specify 3 SRV networks, which will be used by our network function. So here we are looking inside of the virtual center, and we're picking up port group to be used by our SRV adapters. We're taking this name and specifying it in the input parameters. This means that during instantiation, SRV adapters will be plugged into this virtual switch, and worker nodes will be used this virtual switch for external communication over SRV virtual functions. When all required parameters are provided, we will see summary screen of all parameters and all settings which were created, and we can click instantiate. Yeah, now we see that all that functions are here, and let's just click instantiate. Depending on the network function complexity, it will take some time to instantiate network function. And in our case, it will take approximately 5 minutes. And the first step during the instantiation, definitely it is infrastructure reconfiguration to meet all requirements and meet desired state from the specification. basically all set of requirements which were specified inside of the VNF descriptor right now apply to the infrastructure, and each of the worker nodes in our Kubernetes cluster is being reconfigured. As I mentioned, it will take several minutes to deploy network function, and after a while we'll come back to the screen where it was deployed, and we'll see that our network function right now is up and running. And basically we can check, it takes something like 8 minutes to deploy, including customization of the required infrastructure and instantiation of the network function itself. So in this demo, we saw that with TCA, you can flexibly specify requirements for your infrastructure. You can use a set of extra parameters to specify desired state of your infrastructure and potential customization which your worker node should have. And TCA provides this capability to implement them for successful network function deployment. That's all for the demo. Thank you very much for your attention.